Hi everyone. In this video, we are going to discuss how to measure power and energy in different power factors in single-phase circuits. When lagging power factor will occur? Lagging power factors occur at inductive loads like motors, choke coils, etc. The pure inductive circuit draws the current which lags the applied voltage in 90 electrical degrees. This lagging power factor in the inductive loads is due to Lenz's law. Whenever voltage is applied across an inductor, a magnetic field is set up around it. This magnetic field direction will oppose the cause, hence the current lags the voltage. When leading power factor will occur? Leading power factors occur at capacitors. The pure capacitive circuit draws the current which leads the applied voltage in 90 electrical degrees. First, collect the tools, equipment, instruments and materials required as listed below. Single-phase energy meter, disc type. Moving iron voltmeter 0 to 300 volts. Moving iron ammeter 0 to 5 amps. Wattmeter 5 amps at 300 volts. Single-phase power factor meter 250 volts, 0.5 lag to 0.5 lead. Variable lamp load of 1 kilowatt at 250 volts. Tube-light choke coil 40 watt. Electrolytic capacitor 2.5 microfarads at 250 volts. Stopwatch. Insulated copper wire 1 square millimeter. 2-pole MCB 6 amps. Measurement of lagging power factors in single-phase circuits. Take a 40-watt tube light choke L1. Connect an ammeter, wattmeter and power factor meter to the choke coil as shown in the circuit diagram. Connect the voltmeter in parallel to the circuit. Connect the circuit with an AC power supply through a 2-pole MCB. Switch on the MCB. Note down the ammeter, voltmeter, wattmeter and power factor meter readings in the tabulation. Now in the same circuit, connect another 40-watt choke coil L2 in parallel to the choke coil L1. Note down the ammeter, voltmeter, wattmeter and power factor meter readings in the tabulation. Plot the graph between voltage and current, voltage on the x-axis and current on the y-axis, values taken with only L1 and values taken when L1 and L2 were connected together. From the graph, you can observe that the current lags the voltage for L1 readings and that the current gets more lagged for L1 and L2 readings. Hence, lagging power factor is measured in single-phase circuits. Measurement of energy in a single-phase circuit. Connect the ammeter, voltmeter and wattmeter energy meters with a 40-watt choke coil L1 as shown in the circuit diagram. The energy must be of the disc type and properly connected to the phase and neutral terminals as shown in the circuit diagram. Note the energy meter constant displayed in the energy meter. Connect the circuit with an AC power supply using a 2-pole MCB. Switch on the MCB. Ensure the energy meter disc is revolving. Note the ammeter, voltmeter and wattmeter in the tabulation. Now take a stopwatch. By keeping the red colored mark on the energy disc as a reference, triggers the stopwatch and note down the timings for 10 revolutions in tabulation. Switch off the MCB. Now connect another 40-watt choke coil L2 in parallel to the L1. Switch on the power supply. Note the meter readings in the tabulation and calculate the time for 1 revolution in the energy meter using a stopwatch. Calculate the energy. Energy E is equal to power time. E is equal to P into T. Substitute the wattmeter reading in the power P and time measured in the stopwatch at T. Suppose if the wattmeter reading is 50 watts and the time measured is 2 minutes for 10 revolutions, then substitute the values in the formula. E is equal to 50 into 2 upon 60. E is equal to 1.66 watt-hour. Now calculate the energy consumed using the energy meters constant and compare the measured and calculated values to ensure they are the same. If the energy meter constant is 750 revolutions per 1 kilowatt hour, calculate the energy consumed for 10 revolutions in 2 minutes, and that should be equal to 1.66 watt hours. Calculate the energy consumed by two capacitors C1 and C2 connected in parallel. Thank you for watching. Have a wonderful day.